Hey everybody, my name is Adrian Martin. I am in Professor Kalim's malware reverse engineering class, and this is a video that's going to be uh, in which I'm going to go ahead and basically reverse engineer a piece of malware that I found. I'm going to be performing the analysis with. I'm going to be performing several different types of analysis. The first thing that I'm going to start with is the basic static analysis. Then I'm going to move on to a basic dynamic analysis, and then finally I'm going to perform a advanced static analysis to see if I'm able to get an idea of what exactly it is that the malware does. So this video is going to be comprised of two parts. The first part is going to be the basic static and the basic dynamic analysis. After I complete those two, I'm going to turn off the video, turn it back on, and go ahead and perform the advanced static analysis. Now, the reason why I'm going to do this is because my screen capture software has a built-in time limit of 15 minutes. So, in the interest of not having to cut the video short while I'm in the middle of explaining something, I'm just gonna divide it in those two sections. Now, the next thing that I should tell you guys is that um, any analysis that you guys perform uh, at home, in the workplace, wherever it is, this is you're dealing with real malware. Um, if you run the malware, it's very likely that you'll get your machine infected. So it's highly advised that if you run this malware, if you try to analyze it, that you do so in an isolated environment. It could be a virtual machine, preferably on a machine that's isolated on the network, so that if your machine does become infected, that it doesn't spread the virus uh, to other machines. So, with that disclaimer, please be very careful while performing these analyses. This is actual malware that will infect your machine. Okay, so I will be analyzing this piece of malware, which is called opt content. I have gone through the analysis before I started this video, just so that I don't have to be stumbling around and figuring things out. So again, in the interest of time, I'll be basically cutting to the meat of things. Just showing you the tools that you guys can use, and try and see some network and host based indicators or signatures that can help you identify this piece of malware and what exactly it is that it's doing. Okay. So the first thing that I was going to do was that I'm going to perform a basic static analysis. So I have a couple of tools here. Um, the first one that I'm actually going to execute is one called depends. This is a dependency walker, and basically most of the information that I'll get out of this tool is exports and imports that this malware should be using. So I'm gonna go ahead and run it. Okay, then it pops up. So the first thing that I see here that is of great interest are these two imports. So first thing is the kernel32.dll, and secondly is the wininet.dll. So with wininet, it basically gives the malware the functionality of internet usage, mainly at the application level. So it'll have functionality such as HTTP and FTP usage. So if we look here at the actual imports from that DLL that the malware will be using, we see a couple of interesting ones. we see internet close handle, we see internet open URL, and internet read file. So like I mentioned, this right off the bat, it gives us an idea that this malware is actually gonna try and reach out into the internet, uh, say to download something, read a file, probably even get commands off of the file that it gets. So the next thing, let's check out kernel 32 and see. So a couple of interesting imports, such as create a process. So it does have access to opening and closing processes. Let me see, was there anything else interesting over here? Okay, and it also has the ability to write a file. We'll see later on if this is actually put to use. So now we've gone ahead and seen some of the dependencies that this malware is going to be using. We have an idea of sort of where it's coming from. We already know that it's going to be connecting to the internet, probably getting some commands offline, and even changing some files probably. So the next thing that we're going to do is that we're going to see if this malware is packed. Well, we're able to see here that the compiler that was used was Microsoft Visual C++ 6.0. This particular piece of malware has not been packed, so that's a good thing. We'll be able to get a lot of information out of it without going through too much through the hassle of unpacking the malware. Next, in my static analysis, I'm going to try and see some of the other strings that, or actually some of the strings that might be visible within the malware. So I'm going to go ahead and run this utility called strings. I'll just drag it into my command prompt, put in a space, and then I'll drop in the malware. This is just shorthand for not having to write all of the file paths or change directories. It's a lot quicker this way. I'll press enter, and now it analyzes all of the files that are actually visible within this malware. So let's start from the top and let's see what we can figure out from here. Alright, so on the top we have a lot of random stuff. These strings are actually probably just hexadecimal values that it found throughout the program and converted into actual characters. So as of right now, they really don't mean anything to us. We might be able to get a better meaning once we perform the advanced static analysis. So let's see, let's keep going. Alright, so first thing we see here, we're able to see letters of the alphabets, numbers. Keep going, we have some apparently some error handling, probably some error handling. Not enough space, so floating point not loaded. Microsoft Visual C++ runtime library, runtime errors, program, get last active pop-up, get active window, message box, user 32 DLL, that's a dynamic link library. Then probably some functions here, close handle, write file, read file, create process, sleep. It seems that it's importing the kernel 32.dll, which we saw earlier in the dependencies. Then we have the interesting functions which we found from the win-inet DLL that give the malware some functionality with HTTP and FTP. Keep going. Again, we have these are functions that give us an idea of what exactly the malware is or will be doing. So we know that it has access to processes, virtual lock, keep a lock, flush file buffers. Now here, look at this. Okay, user agent. Apparently here we have a 96. This might be interesting. We have user agent. So this signature here would actually be used most probably while it's trying to connect to the internet. It should be using the Mozilla 4.0 browser. It's basically just a way to handshake with the remote server that is trying to access and get the information that it wants from it. We have the language that it's going to be using. It's English. It's going to accept all types of file from all directories, or I'm sorry, all directories. It's meant for a 32-bit operator. Looks like Intel. The file that I might be able to accept, a gzip file. Let's keep going. Here we have an executable in the C drive. C autobat. It might actually unpack that executable or install that executable in the C drive. That's interesting. Okay, and here we're reaching the end, and here we actually have a URL. Now this is, given that this is a school project, and I'm not showing the URL because it's somewhat explicit, so I don't want to put this content up on YouTube. I don't want the words to be seen by school or anything like that, just to avoid from getting in trouble. But this is a URL. It's an HTTP, so it's very likely that it will be connecting to the internet using the HTTP protocol, and it actually has a file which might be the one that is downloading. It's called start.htm. Alright, and so that's the end of my strings analysis. Okay. Now the next thing that we're going to do is that we're going to go ahead and we're going to perform the dynamic analysis. So basic dynamic analysis, the first thing that I'm going to do, I'm going to minimize all of this, and I'm going to open up some of the utilities of interest to me. I'm going to open up my process explorer to monitor processes. I'm going to open up process monitor. I'm also going to take a picture of my registry just to make sure that it's in good condition. I'm going to compare it just to get a baseline. I have short appay DNS. This is a utility that allows me to redirect any traffic coming out of my NIC card to whatever port I want. These are DNS requests that I'll be redirecting. So I've already taken the first shot of my registry. I'm going to take a second shot of my registry. The name of this program is RegShot 1.90 for a 32-bit processor. Okay, so it's almost done, and now I'll be able to compare it. Okay, so 2 files added, 14 modified. Okay, so that's somewhat my baseline. Alright, let's clear everything again. Alright, so the next thing that I'm going to do is that I'm going to go ahead and redirect all DNS queries to my local host using app8 DNS. I was able to successfully start the server. Good. Okay, so since I'm going to be redirecting DNS requests to my local host, I need something to listen in to the port, or listen to those requests, see what exactly it is that it's requesting. So I'm going to open up netcat, which is a utility that's going to let me do exactly that. So I'll be able to give it these flags -L to listen, -P for port number, and the number 80 for port 80, which is actually HTTP port. Alright, so looks like we have everything running. Let me just check one more time. Okay. We're not going to need Wireshark. First of all, we should see what exactly it is that this thing is doing. Alright. So now I'm going to run. I'm going to run the malware and see what processes pop up when I do run this malware. Move this to the side. Okay, so I'm going to run it. Alright, so we have this opt content here, which popped up. Okay, so and we have this request that was received on port 80 from netcat. It was a request sent to the actual domain name, which we found in the strings previously, and we're actually able to see it here as well. And hey, so the process just terminated. The malware just terminated itself. Apparently couldn't find anything, so it just killed it. Okay, so we're able to see here, yeah, exactly what we saw in the string command earlier. Alright, so I'm going to go ahead and stop this, cut everything off. I'll turn this off and get things ready for, oh, okay, almost forgot. Let me go ahead and take the second shot of my registry to see if there were any changes with respect to the baseline. I'm not going to be looking at any processes because it didn't seem to spawn any other processes, so I don't need to use Process Explorer or Process Monitor. So since my reg shot finished, I'm going to go ahead and compare it. And would you look at that, there are first we saw that there were only 2 keys added in the baseline. Now there's 37. There's a couple that were deleted, values that are added, values modified. Alright, from my previous analysis before I did the video, I didn't really find anything too interesting here. Nothing like making itself a service for persistency. You saw yourself that that the malware actually just terminated itself. So there are a couple of changes that were made because of this malware, but nothing that I am able to determine that it's something of value, at least not with the knowledge that I have up to now. Alright, so I'm gonna go ahead and close this, close my registry shot, and then I am going to get ready for I'm gonna go ahead and get ready for the advanced static analysis. Alright, so until then, bye guys. Alright, so I'm back, hopefully with the last segment of this video. Now I'm gonna go ahead and perform the advanced static analysis. So in order to do that, I'm gonna go ahead and open up the folder containing the malware, and I'm gonna run it, or I'm gonna open the malware on a program called Idea Pro. This is a free program, um, and or this is the evaluation product, the evaluation version of this product, which is Idea Pro. It's a very good program actually. So this is a disassembler. So what this does is that it takes the binary, obviously the binary state in which the malware is in, and then it disassembles it. By disassembly, it means that it actually takes it from zeros and ones, which is just machine readable code, to assembly code. Alright, so here we go. Alright, so the first thing that we do is that we go into our main function. This is the first place that our disassembler takes us to. So this is quite a bit of code, and if you focus on the little things, you're going to get bogged down and just waste a lot of time. So let's go straight to the meat and potatoes, so to speak, where is the function calls. So if we come here, this is the first instructions. Let's keep going until we find our first function call. Here we have a memset, which is a call. Alright, so here we have this subroutine. Let's follow it by double clicking, and let's see if we can figure out what exactly it's going to be doing. So if we follow these instructions, we see here that there's a call to create a file, and we see that the parameters that are taken by create a file are actually the ones above, and one of them is c autobat.exe, which saw this previously. So we know that there's going to be a file that's being created in the C folder called autobat.exe. And we go down, further down, we see here that we're giving as a parameter, we're giving a URL to this next function call. So we know that there's going to be a file being created, then it's going to call this function here, which takes a parameter, a URL parameter, and let's see what exactly it is that it's going to do with that. Alright, so there's a call to a copy, to a string copy, to string length. Apparently it's copying the parameter that I received, checking the size, and then it's going to create another file here while taking again the same parameters, but in this case it's actually going to be taking the string copy is going to be taking in the name of the URL that it provided it. So we go further down, we have write file, close handle, so it's going to close up the handle, and it's going to end the subroutine, so it's going to return back up. Alright, so let's keep on going down to the next subroutine. Let's see what happens here. So here we have an LP buffer. Okay. We follow that subroutine, and again, pretty much the same thing. This is a call to the same function, I guess. So just as there's still a lot of things that I have to learn, but this is just a basic overview of some of the techniques that you guys will be able to perform as malware and analysts. This is a very powerful tool. It takes some time to analyze some of this malware, but it's worth it. It's fun, and it's something new. So this is the end of my video, of my project video. I hope you guys enjoyed, learned something from it, and I hope I get a good grade out of it. Alright, so until next time, bye.